Assalamualaikum warahmatullahi wabarakatuh, and you're watching problem-based learning for subject calculus from group 11. First of all, let us introduce ourselves. Hello, my name is Muhammad Ali Faikal bin Muhammad Aris, and my matrix number is 200194.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Hilmi bin Muhammad Faizal. My matric number is AA 201007.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fahmi bin Muhammad.
Today, we are going to discuss the problem given, which is case 1 and case 3. Without further ado, let's begin.
I want to explain about the case 1. The question is, designing model and architecture students plans to design a model that contains a right circular cone and cylinder. The right circular cone measurement is radius 9 cm and the height is 11 cm. Find the radius of height of the right circular cylinder of largest volume that can be inscribed in a cone.
Before going to the solutions, there are several facts that we need to know. First, this question is about an architect student that plans to design a model that contains a right circular of cone and cylinder. Next, the right circular cone measurement is radius 9 cm and its height is 11 cm. Next, we need to find the radius of height of the right circular circle of the largest volume that can be inscribed in the cone. From the questions, we have the ideas that the radius of the right circular cylinder must be shorter than the radius of the right circular cone. Next, we know that the height of right circular cylinder must be shorter than the height of right circular cone. Furthermore, we must use the formula of right circular cylinder and cone. Lastly, we must use the concept ratios. As a student, a few questions shall arise in order to answer the questions. First of all, what is the radius and height of the right circular cylinder? Next, how to use the formula and how to use the concept ratios. To answer these questions, we let Aiman to do the rest.
So first we use the ratio concept that y over x equal to h over r. So 11 minus h over r equal to 11 over 9. So we do the equation that the h equal to 11 minus 11 r per 9. So we got the equation that h. So use the formula of cylinder to find the volume. So the formula volume of cylinder is pi r square h. So we got the h. We got the equation of h. So we insert the h in the into the formula. So pi r square h multiply 11 minus 11 over 9. So we got the volume of cylinder that 11 pi r square multiply 1 minus 1 per 9 r. So we use the product rule that dv over dr equal to u multiple v prime plus v multiple u prime. So u prime is u is 11 pi r square and u prime is 22 pi r. V is 1 over 1 minus 1 over 9r and v prime is minus 1 negative 1 over 9. So we use the product rule that u multiple to v prime plus v multiple to u prime. So 11 pi r square multiple to negative 1 over 9 and plus 1 minus 1 over 9 r multiple to 22 pi r. So we got the answer that negative 11 over 3 pi r square plus 22 pi r. So we got the r in bracket r minus 6. So we do the dv dr equal to 0. So r equal to 6. So we got the answer that radius is 6. So when we got the radius 6, we can find the h. So we insert the r into the formula and h equal to 11 minus 11 over 6 multiple to 6. And the answer for h is 11 over 3. So the radius is 6 and the height is 11 over 3. So when we got the radius and height, we can find the max volume. So we use the formula pi r square h. We insert the radius and height. The max volume is 132 pi cm cube. So we got the maximum volume. So the conclusion is, first we must know the height and radius of right circular cylinder to find the maximum volume. So we use the concept ratio and equation to solve this case. Based on the working solution, the knowledge for the formula of volume is a must to show our standing for the problem given. Other than that, we also use differentiation method to apply to solve the problem. Finally, we got the head and radius of right circular cylinder that 11 over 3 cm and 6 cm. Therefore, we got the maximum volume of right circular cylinder is 132 pi cm cube. That's all from me. Thank you.
Let me brief a little bit for case study 3. Case study 3 is about Aminah, who decides to move first step by fencing her home area, which is a rectangular plot, by using barbed wire due to the robbery and kidnap cases that are increasing in her neighborhood. So she intends to use two different types of fence, which is one is the heavy duty fencing, which costs 30 ringgit per meter, and the other one is the standard fencing, which costs 15 ringgit per meter. So what we need to solve is we need to find the dimension of the maximum area that can be fenced in a cost of 30,000 ringgit.
Hey, it's me again. Let's talk about the facts from the questions. First, Aminah decides to fence her home area due to increasing of robbery kidnap cases. Second, her home area is rectangular in spot. Third, she intends to use two different types of fence, which is heavy duty fencing, which costs Rm 30 ringgit per meter, and standard fence, which costs Rm 15 ringgit per meter. And the fourth one is the budget that Aminah has is Rm 30,000 ringgit. To being able to answer these questions, we must have the ideas behind it. First, the sides and the width must be different in length. Second, we must draw to imagine how the home are like. Next, we need to form equation to get a clearer ideas. Next, we need to know the formula of area, and lastly, we have to apply a differentiation method. A few questions arise, which is what is the length of the sides and the width of the home area. Second, What is the dimensions maximum area that can be fenced in a cost of Rm 30,000 ringgit? And how to use the area formula? And lastly, how to do the differentiation? To answer these questions, we let Fahmi to do the solution.
So for the solution, first step is we need to form two equations, which is one is the perimeter equation, which is 30x plus 60y equals to 30,000, and the other one, the second equation is area, which is A equals to x times y. And then the second thing is the perimeter equation, we need to modify it a little bit, which is we need to put the x as a subject, so it will be the third equation. And then when you find out the three equation, 1, 2 and 3, and then the next step is you need to substitute third equation into second equation. And then after you substitute third equation into second equation, you need to find the value of y, right? So what you can do is you can differentiate it, and then after you can differentiate the equation that you already substitute the third equation into second equation, the result you should equal it with 0, and then you can find the value of y, which is 250. So when you find the result of y, which is 250, you need to substitute it back in equation 1, and then after you substitute the value of y into the equation 1, then the last one is the conclusion. So in conclusion, we know that to solve this kind of case study, we need to identify the length of the sides and the width. To identify it, we need to form equations that can relate to the statement to get a clearer way to solve it. And based on the working solutions, the knowledge for the formula of area is a must to show our understanding for the problems given. Other than that, it also requires us to use differentiation method to be applied to solve the problem. And finally, by applying all the methods mentioned above, we will know that the length of the side and the width are 500 meter and 250 meter. Therefore, the dimension maximum area for the house area to be fenced is 500 meter times 250 meter.
That's all from Group 11. See you next time.